All right, guys, so welcome back. So we are at now day 4 of what looks like probably 5 days of quadratic equation word problems before we move on to something new. So we're going to review some of the problems, the painting and the walkway problems that we looked at yesterday. We'll look at one of those. And then after that, we will start to look at some changing dimensions type problems. We'll call them perimeter problems. So this first one says a painting has a length that's 1 foot less than 3 times the width. Okay, so if we're going to call the width x, then 1 foot less than 3 times the width would be 3x minus 1. And it says around it is a frame that is 3 feet thick, right? So we know on all sides that this is going to be 3 feet. And again, guys, I don't need to necessarily draw every corner, but I think for some of us the consistency probably helps. So let's do the harder part first, right? So I've got 3x minus 1 units here, plus 3 plus 3. So if I want to write it out, I've got 3x minus 1 plus 3 plus 3 should actually give me 3x plus 5. So that's this dimension, that's the length. Now the other one I'm hoping should be easy, right? I've got x plus 3 plus 3. Which hopefully we understand is x plus 6. So now let's go back. So it says the area of the frame only is 126 square feet. So let's take a look at the frame. Well, again, the area of the frame is this. So the area of the frame is the outside, subtract the inside. Right, that's the area of our frame. So let's find the area of the outside. Well, the area of the outside is going to be 3x plus 5 times x plus 6. And the area of the inside is going to be x times 3x minus 1. And that's equal to, I believe we said 126. All right, so this has got to be subtracted. So we said yesterday that it is a big deal that we're going to make sure that we put this in brackets here. So what's going to happen? Well, I'm going to do the FOIL here, right? 3x plus 5 times x plus 6 is 3x squared. Then I've got 18x and 5x is 23x. And I've got 30. Subtract 3x squared minus x. So again, I need to make sure that I distribute this negative. So when I bring all my terms down, I've got 3x squared plus 23x plus 30 minus 3x squared plus x. And that whole thing's equal to 26. I don't really have a lot of space to work here. So I've got 3x squared minus 3x squared, which is 0. Thankfully, that helps us. 23x plus x is 24x. Plus 30 equals 126. So I got a nice, easy two-step equation. Wasn't exactly easy to get it, but I have a nice, easy two-step equation. So that gives me 24x is equal to 96, which means that x is 4. And again, guys, it's great that we got 4 instead of, 19/3 or something like that, but we still should go back and check it and make sure we did this correctly. So if x is equal to 4, then 3x is 12, minus 1 is 11. And x is 4, x plus 6 is 10, and 3x is 12 plus 5 is 17. So we'd expect the area of the outside subtract the area of the inside to be 126. So the area of the outside is 17 by 10, right? So that's 17 times 10 is 170. And my area of the inside is 4 times 11, which is 44. And 170 minus 44 is 126. So that's our proof that we did this correct. So that's a review of what we did yesterday, which obviously was a lot, right? I only assigned one of these for homework. They do take a long time. You see I'm up to about 4.5 minutes, and I did this pretty fast. Today's are going to be a little bit easier, right? We're only going to do, I think, 2 of them today, and then we'll get to our now try. These should definitely be a little bit easier. We're past, like, the real tough stuff here. All right, so on top it says changing dimensions problem. Okay, so let's see what we've got. It says a square field. So I'm going to stop right there. right? You tell me that I've got a square, right, that's unknown, and I know that in a square the sides are all equal, so I just call the sides x and x. So algebraically, that's the first thing we do if we're dealing with something that's got equal dimensions. But specifically, what we'd see here would be a square. Now it says its length is doubled. Now the length and the width are kind of subjective. They're the same. And its width is decreased by 3 feet. All right, so one of these x's is going to be doubled, and one of these x's is decreased by 3. So we're going to have a longer but thinner figure. So let's imagine that this is my new rectangle. So I had a length here of x units. Now it was doubled. So I'm going to call this now 2x units. And I had a width here also of x units, but that was decreased by 3, so I'm going to call that x minus 3. Now it says the resulting rectangle, which is here, has an area 7 square feet greater. So why don't we find the area of each of these? Well, the square obviously is going to be easy. The area of my square is x times x, which is x squared. How about the area of my rectangle? Well, the area of my rectangle is going to be its length times its width, which is going to be 2x squared minus 6x. So now let's write the equation. The resulting rectangle, which is this, has an area 7 square feet greater than my square, which is this. Okay, well that shouldn't be too difficult, right? The area of my rectangle, which is 2x squared minus 6x, equals 7 more than my x squared. All right, so that's my equation. Again, my area of my rectangle, which is on my left, 2x squared minus 6x, equals 7 more than the area of my square, which is x squared. So I'm going to try to move both of these terms in the same step. So 2x squared minus x squared is x squared. Negative 6x and negative 7 are not like terms, so they just come down. And I've got a very simple quadratic equation in standard form. I can factor it as x minus 7 times x plus 1. So this is x minus 7 equals 0. This is x plus 1 equals 0. So one of my solutions is 7. And one of them is negative 1. Now, can a square have a side length of negative 1? Of course not. So we're going to reject this. Right? We said with problems like this, a negative value is going to be rejected. Yeah, I can substitute negative 1 into my expressions and it will check, but it's not going to make sense in a real world problem. So x is equal to 7. Now let's answer the question. What are the new and original dimensions? Well, my original dimensions, my square, was 7 feet by 7 feet. Now let's talk about my rectangle. Well, if x is equal to 7, then x minus 3 is 7 minus 3, which is 4. And 2 times 7 is 14. So my rectangle is going to be 4 feet by 14 feet. Well, let's make sure it checks, right? So what are the dimensions? I answered the question here, and I answered it here. Now my area would be 49 square feet. And my area here would be 56 square feet. And as predicted, right, 56 is 7 greater than 49. So we can check that we did this correctly very easily. So this is an example of what we'll call a changing dimensions problem. All right, and let's take a look at one more. So I always put on the slides not a picture frame problem, because when I personally see this problem, I always set it up as like I'm doing a picture frame problem, and then I kind of have to step back from it. So I've got a 5 by 9 rectangle. Okay, so this is 5 and this is 9. I'm going to label inside actually, and we'll see why in a minute. It says, has each dimension increased by the same amount? So what happens if I increase this and increase this? Well, if those lines I drew are the same amount, then I could say that those are x units long. Now, what would my full rectangle look like? Well, my full rectangle would now look like that. Well, how big is this side? Well, this is 9 units, and this is x units, so the whole side is 9 plus x. And this is 5 units, and this is x units, so this is 5 plus x. Now let's see what they tell us, right? If they told us what the outside area is, we'd say, well, that's easy. X plus 5 times x plus 9 is equal to whatever the area is. But they tell us that the new area is 120 greater than the original. All right, so now we got to find, well, not that this is too difficult. Let's find the original first. So the original area is just 9 times 5. That's going to be 45, and I'm not going to label the units until I'm done, but it's 45 square feet. Now let's think about the new figure. Well, my new figure is going to be, I'll put it down here, 9 plus x times 5 plus x, which is the same as x plus 5 times x plus 9, which if we do the FOIL, we should get x squared plus 14x plus 45, which is what I'll bring up here. So now it says the new area is 120 greater than the original. All right, that should be really easy then. My new, right, x squared plus 14x plus 45 is 120 greater than the original. Well, the original is 120, so 45 greater than that would be this. Now, really what I would do if I was doing this in class is, looking at this right now, I'd cross out the 45s, right? In other words, I'd add negative 45 on both sides. But for the sake of consistency here, I'll solve it the kind of more conventional way, where I'm going to actually put it in standard form, which gives us x squared plus 14x minus 120. So I should be able to factor this pretty easily. X plus 20 times x minus 6. All right, so I've got, I'll bring this, I guess, over here. I've got x plus 20 equals 0. And I've got x minus 6 equals 0. So I've got x equals negative 20. And I've got x equals 6. And again, right, can't have a rectangle with a side length of negative 20, so this one will be what we call rejected. And that tells me that it's 6. Now, what are the new dimensions? Well, if x is 6, then 5 plus 6 is 11, and 9 plus 6 is 15. So my new dimensions are going to be 15 feet, right, by 11 feet, which means 11 times 15 gives me an area of 165 if I want to check it. So my outside rectangle is 11 by 15, which is 165. My inside one I already knew was 45, and the outside would then be 120 greater, right? So there's my check. Right, so we're at that point here, guys, where you'd be able to try this one on your own, okay, or these two on your own. You would pause it now, and then you'd wait for me to come back and go over it with you guys. So the first one says a rectangle with a length 4 times its width has its length doubled and its width decreased by 1 centimeter. So let's start here. The length is 4 times the width. It says it has the length decreased, doubled, and I believe it's the other one is decreased by 1 centimeter. All right, let's take a look. So if I double 4x, that should give me 8x. And if x is decreased by 1, that's x minus 1. Now I know I'm going to have to find my areas, so let me find them now. My area here is x times 4x, which is 4x squared. My area here is 8x times 8x times x minus 1, which is 8x squared minus 8x. Now it says the a new rectangle has an area of 12 centimeters larger. Okay, so my new one is equals 12 centimeters greater than my original. Okay, so again, as always, I'm going to move my terms here. So now I'm looking at 4x squared minus 8x minus 12, and I am not going to even think about using my 5-step method until I look for a common factor, which I can tell right away is 4. X squared minus 2x minus 3. Well, that should be a nice easy one to factor. So I'm looking at x minus 3 times x plus 1. So I've got x minus 3 equals 0. I've got x plus 1 equals 0, which should give me x is 3. And this should give me x is negative 1, which again we will reject as a negative value. It's what we call an extraneous solution, which means x is 3. And that's when I think I could leave you guys. Those of you that are doing it, we can go back and check it on our own. And let's take a look at the second one. It says a 3 by 11 is increased by the same amount. Now I gave you an easy one. It says the new area is 128. Not 128 greater, just 128. So I'm going to draw my 3 by 11. Right, so there's my 3, there's my 11, and I'm going to increase it by the same amount. So there's an additional x units, there's an additional x units. So if that red part is 11 and that gray part is x, then this is 11 plus x. And for the same reason, if this red part is 3 and this part is x, then this is 3 plus x. And again, it simply said that the new rectangle was 128, meaning that 11 plus x times 3 plus x is 128. We don't have to do any subtraction here. They didn't say it's 128 greater. So I'm going to do my FOIL. I've got x squared, I've got 3x, and I've got 11x, which is 14x. And I've got 33. So I should end up with x squared plus 14x minus 95. So that's going to lead me to x plus, x plus 19, x minus 5. So we get our two solutions, which are x are 5 and x is negative 19. And again, negative 19 gets rejected as a result of it being negative. So we're going to say that our value of x is equal to 5, and you guys should then be able to sub it in and check. All right, so these are examples, guys, where, when you're doing the homework, which is only going to be one problem, you may want to write some comments. You may want to ask some questions. This is not going to be easy for everyone. Okay, so I did my best to make the homework directly model the problems that I modeled in class, especially the now try as well. So make sure if you're having any problems that you give it your best try. You submit me a picture, or even beforehand, you ask me about it. And if I have to, I'll get you guys set up. I'll text you guys a picture of it, or I'll post a picture of what it should look like.